Right, thank you. So my name is Vera Stavroulaki, as already introduced. I'm with Wings ICT Solutions, which is an SME based in Greece. Wings develops different solutions for various vertical domains, including both the hardware and the software part. This security and privacy is also new for us, so to connect it also with Professor Murphy's speech earlier, we are not experts in this, but we are evolving. Now, Confidential-6G is looks into confidential computing and privacy-preserving technologies for 6G. It is a project under the Horizon Joint Undertaking Smart Networks and Services in the specific topic of secure service development and smart security. It's a 3-year project which started in January last year, so we are roughly at the middle of the project at the moment. The total budget is about 5 million euros, and we have a consortium of meanwhile 14 partners with 4 SMEs, 3 industrial partners and 7 academic and research organizations from 8 EU member states. Myself, I am the project coordinator, and the technical manager is Drasko Draskovic from Abstract Machines, an SME based in France. To give a bit the overall context of the project, so, okay, we consider that 6G infrastructures must, of course, ensure reliability, trust, and resilience on a globally connected continuum of heterogeneous environments, which is supported by the convergence of networks and IT systems to allow future digital services to flourish. And of course, this increase in coverage and network heterogeneity raises even more severe concerns about security and privacy. So in Confidential-6G, we'll look into this vision of 6G systems as a deep integration of emerging AI tools, new hardware components and accelerators, networking functions, computing functions, IoT and edge nodes. And obviously, security needs to be enhanced. In this sense, Confidential-6G emphasizes on privacy preservation and enhancing security of sensitive data by focusing on data protection in use, in transit, and at the edge. In use is where confidential computing comes into play. This is an unresolved issue. In transit, Confidential-6G looks into enhancing communication protection by exploiting blockchain technology, post-quantum cryptography, and traceability platforms, just to give some examples. And at the edge, we are looking more into identifying approaches that are most appropriate for constrained IoT and edge nodes and devices, as well as federated learning, so that data do not have to move from the edge, and thus trust and security is enhanced. Here we can see the project objectives. So the project focuses on 3 main pillars: post-quantum cryptography, confidential computing, and confidential networking. And in this context, we are looking into, first of all, looking into the state of the art, analyzing security threats, and being able to, through this analysis, to identify and specify quantum-resistant security enablers, cryptographic primitives, libraries and tools, both for confidential computing as well as confidential networking, that can be applied in 6G and this global edge cloud continuum. We want to have prototypes, or let's say develop prototypes of these mechanisms for confidential computing based both on hardware and software mechanisms. Design and develop secure and privacy-preserving edge cloud networking that is suitable for collaborative confidential computing orchestration, distributed and federated machine learning operations, and then integrate at least a selection of these developed tools and mechanisms in the different use cases that we are looking into to validate at least as much as possible of the solutions developed in the project. And of course, okay, as an EU project, one important objective is also to have some impact with contributions to standardization, disseminating project results as much as possible, and ideally also exploiting these results either in further research or in the future also in products of the consortium participants. So this is just to indicate the rough structure of the project and some of the areas. So as I mentioned, the three main pillars are confidential post-quantum cryptography, confidential computing, and confidential networking. And there we are looking into different cryptographic enablers, tools, and libraries, trusted execution environments, fully homomorphic encryption, secure multi-party computation, federated machine learning, and so on. And of course, as I said, also the practical verification through three use cases. So the first use case we are looking in is dedicated to predictive maintenance for airline consortia using blockchain-based data sharing platform and federated AI orchestration. The idea here is that if we look into airline consortia, there are a lot of data, for example, related to the maintenance of aircraft. This is a big amount of data through which companies could also get insights on different maintenance issues, best practices, and so on. But of course, they are not really willing to share the data. So this is where, or if they are willing, then all of these security and privacy preservations come into play. So here the focus is really on making sure that if data is shared, it is secure and traceable, and also that federated learning can be exploited to learn on top of the shared data, but also minimizing the need to actually exchange the data itself. The second use case is more focused on telecom cloud providers, so providing a confidential computing platform that emphasizes on privacy preservation, enabling mitigation of different security threats. Here it's more about cryptographic enablers, hardware platform abstractions, remote attestation handling, and so on. The third use case focuses on intelligent connected vehicles for providing mission-critical services, over-the-air updates, and also exploiting federated learning for vehicle-to-infrastructure communication, again, minimizing the need for data to be necessarily exchanged as is. And here we are looking at different applications, like, for example, gaining insights from the connected vehicles on driver behavior, on upcoming traffic, or again also on predictive maintenance issues that have to do with the vehicles themselves, or also the roads from data that is collected from the vehicles. So one of the key areas, as already mentioned, is more related to this post-quantum cryptography, and the key goal is to produce a so-called confidential toolkit So here we start first from analyzing security threats in the quantum area, and then from that trying to define toolkits for trusted execution environments and post-quantum computing, toolkit for fully homomorphic encryption and secure multi-party computation, and a toolkit for blockchain and zero-knowledge proof. All of this, as I mentioned in the beginning, the idea is that we have a toolkit with different also best practices that can be applied in 6G networks and this edge cloud continuum that we are envisioning as part of these 6G networks and systems. So at the moment we have already produced a post-quantum analysis report which contains an analysis on the threats and the different tools that are available today, as well as an analysis of how challenges towards post-quantum cryptographic infrastructures can be addressed. And the next steps are to progress with the other three types of toolkits that I mentioned, which essentially will be a toolkit for confidential networking, for confidential computation, and blockchain. So these address also feasibility aspects of the different that are related to these different toolkits. In terms of confidential computing, here we started from identifying requirements and architectural blueprints for privacy-preserving computation, with the aim, to research modern confidential computing enablers, advance as much as possible existing techniques for collaborative artificial intelligence and machine learning and multi-party computations, and enhance privacy-preserving computations on the far edge and constrained devices, identifying, as I said, also what is more suitable for these types of nodes and devices. Here again, the first step, let's say, has been achieved in the sense that we have a first report on the requirements and architecture for confidential computing in 6G. You can see a high-level architecture for privacy-preserving computation that has been derived through this analysis. Let's say with key components focusing on data protection, secure computation, trusted execution environments, hardware security models and modules and accelerators. And then the next steps are going deeper, of course, into the design and development of these individual components, looking into hardware modules for supporting confidential computing, confidential multi-party AI/ML, and embedded confidential computing, so focusing again more on the resource-constrained nodes and devices. In the confidential networking, similarly, we start from the requirements and the architectural blueprints for confidential networking, and then we look more into confidential orchestration aspects, considering also the interplay with confidential computing, and again looking into specifically this edge cloud continuum aspects, remote attestation handling, and so on, as well as here looking also into decentralized data sharing enriched with post-quantum cryptography and cryptographic protocols applied to the network layer. And finally, federated AI/ML, focusing on the edge. Again, here we have a report, meanwhile, on where we have analyzed the requirements and architecture for confidential networking in 6G, with some first views on how this high-level architecture for confidential networking can look like. focusing mainly on the confidential orchestration, data sharing, exploiting distributed ledger technologies, federated AI ML, and post-quantum transport layer security. And this is now where we are going to go into further details. So defining in more details and developing this, let's say, individual areas or components of this high-level architecture. As an example of a technical achievement so far in this area of confidential networking, but also related to the confidential toolkit, there is some work already on the blockchain toolkit part, which has to do with self-sovereign identity with zero-knowledge proof, coupled with distributed ledger technology for the management of decentralized identities and verifiable credentials. So there is some first work and implementation on this by Zentrix, one of our partners. This is just, again, a view of the different aspects that we are looking into with respect to validation in the different use cases. I will not go into all of these details, but just to mention that, for example, for the predictive maintenance in use case 1 for the airline consortia, one aspect is also looking into confidential smart contracts and transactions in distributed ledger technologies. In the second use case, which is more for the telecom cloud providers, as already mentioned, one aspect is trusted execution environment abstractions to allow cloud providers to enable trusted execution environments very easily in the cloud. And in the third use case, using, for example, blockchain for ensuring security and tamper-proof of shared models. Again, as an example of work that is ongoing in the, with respect to validation, we have also a first implementation of federated learning applied to deriving insights on driver behavior and upcoming traffic. And for demonstration purposes, this is accompanied by such a UI where we can have a view on different parameters that can be collected from the vehicle OBU, for example. Indicative references, of course, point to start with is the project website. There you can find information on public deliverables, download the public deliverables. This is a list that is corresponding also to the first results that I was mentioning before. The latest deliverable, secure decentralized data sharing, will be actually available at the end of June. But the other three are already available and can be downloaded from the website. And yeah, this is also just a link of indicative papers. Further available papers can be also found on the project website. Thank you very much for your attention.